Have you ever wondered what happens when we take a massive AI model and try to make it ours? It's like moving into a pre-furnished house. You get the beautiful decor, but you also inherit everything hidden behind the walls. Today, we're diving into the hidden security risks of AI fine-tuning. This isn't just about making models smarter. It's about the security inheritance tax every organization pays when they deploy a model they didn't build from scratch. Training a large language model from scratch is an astronomical task. It means assembling trillions of tokens of data, acquiring massive compute infrastructure, and running a training job that can cost tens of millions of dollars. For most organizations, that's not a realistic option. Instead, the dominant model for AI development today is to start with someone else's work. We call these pre-trained models. A pre-trained model is one that has already been trained on a large, general-purpose dataset. These base models learn broad language understanding, grammar, facts, reasoning patterns, and world knowledge. They're produced by a small number of well-resourced organizations and then made available, either through open weights like Meta's Llama family or through API access like OpenAI's GPT series. They are the foundation of modern AI, but they come with a hidden history. Fine-tuning is the process of continuing to train one of these pre-trained models on a smaller, task-specific dataset. For example, a healthcare company might fine-tune a base model on clinical documentation to improve its understanding of medical terminology. A law firm might fine-tune on case law. The result is a model with the broad capabilities of the base model, now specialized for a particular domain or use case. It sounds perfect, but there's a security concern sitting right under the surface. When you fine-tune a pre-trained model, you inherit everything that model already contains. This includes things you cannot see and did not choose. Biases baked in during pre-training persist. Unexpected behaviors introduced by the original training data carry through. And most importantly, any safety alignment built into the base model is not as durable as it might appear. You are essentially deploying the entire pre-trained base beneath your specialized work. Think of safety alignment like a well-worn path through a forest. The model has been trained to follow this safe path when generating responses. Fine-tuning is like adding new paths through that same forest. Even if those new paths are legitimate, like teaching medical terminology, they can gradually obscure the original safe path. The model hasn't forgotten how to be unsafe. The probability weights have just shifted, making unsafe responses more likely again. The defense mechanisms don't snap, they wear down. Research has found that fine-tuned models are measurably more susceptible to prompt injection than the base models they were built on. The reason is structural. Fine-tuning narrows the focus, which can reduce resilience to unexpected tokens. Think of it like this. A model fine-tuned on financial records gets better at financial reasoning, but also becomes more responsive to an attacker who frames their prompt in financial terms. The very specialization you want creates a new way in. Version matters, and it's rarely tracked. Fine-tuning always targets a specific checkpoint of a base model. If that checkpoint later turns out to contain a backdoor or problematic training data, every derivative inherits it, regardless of whether anyone downstream was told. Without knowing exactly which version a model was fine-tuned from, there's no way to assess that exposure after the fact. We are building on foundations we haven't fully audited. When your organization deploys a fine-tuned model, you're not just deploying the work your team did, you're deploying the entire pre-trained base beneath it. That base was shaped by a process you didn't control, on data you didn't audit, by an organization whose supply chain you almost certainly haven't reviewed. Fine-tuning is a powerful tool, but it doesn't sanitize what came before. Understanding this inheritance tax is the first step to building truly secure AI. Thanks for joining this deep dive.